Moving on to the next example, we have to find the derivative of the function cot x. Now, cot x, or cotangent, is the reciprocal of the tan function. And then if you remember, tan x is equal to sine x over cos x. So the reciprocal of that would just be cos x over sine x. So we could rewrite 1 over tan x as cos x over sine x. Right? Because again, cotangent x is the reciprocal of tan x. So the reciprocal of tan x is just cos x over sine x. And now it's a lot easier to find the derivative because it's in terms of cos and sine, and we know how to work with those. So the derivative, notice how we have to apply the quotient rule here. We would take the derivative of the numerator, so the derivative of cos x is negative sine x. Multiply it by the function in the denominator as is. Minus the function in the numerator as is, this cos x, times the derivative of the denominator, which is cos x. The derivative of sine x is cos x. And this is all over the function in the denominator squared, so sine squared x. And then notice how we can simplify this. So sine x times sine x, that ends up being negative sine squared x. And then cos x times cos x, we keep this negative here, is cos squared x. And this is all over sine squared x. Then notice how we could factor out a negative from the numerator. So we'd end up having sine squared x plus cos squared x all over sine squared x. And then if you remember the trig identity, sine squared x plus cos squared x, what does that equal? Well, that just equals 1. So we could sub in 1 there. So we'd have negative 1 over sine squared x, but let's rewrite that as sine x, and this will all be squared, right? Because we would have negative 1 over sine squared x, and then that's the same as 1 over sine x squared, because if we distribute the exponent to the numerator and the denominator, 1 squared is just 1, and then sine x squared is just sine squared x. And then, if you remember, 1 over sine x is equal to cosecant x. So we can sub in cosecant x here, squared, and then the proper way to write that would be cosecant squared x. So that here ends up being our final derivative for cotangent x. So let's do a little recap of what we did. We rewrote cotangent x as 1 over tan x, and then 1 over tan x is just the reciprocal of sine over cos, so it's cos over sine. Then we applied the quotient rule. We got to this point, factored out a negative 1, and then in the numerator we had sine squared x plus cos squared x, and that's equal to 1 by a trig identity. So we end up having negative 1 over sine squared x. Then we rewrote that as 1 over sine x squared. And then cosecant x is equal to 1 over sine x, so we subbed cosecant x for 1 over sine x. And then we rewrote that as negative cosecant squared x. So that's the final derivative for our function cotangent x.